Welcome you all to dieselship.com. This series of educational videos is presented to you by Sriram. And this video is especially produced by Dieselship Academy. And in this video, we're going to see about the water hammer. There are different types of water hammer, and in this video, we're going to see about the condensation induced water hammer. So now we are going to see about the condensation induced water hammer. For that, we'll start with this arrangement, simple arrangement. Here we have a simple globe valve or a gate valve, and here is the pipeline. And let's say this is a steam pipeline. I shut this valve and kept the steam pipe for a while without the lagging. So what happens is the remaining steam gets condensed over a period of time as it doesn't have any lagging, and as the steam condenses, we know that the ratio is approximately this is it. So if we have 1750 meter cube of steam, it will condense into 1 meter cube of water, which means there's going to be a slight partial vacuum after the condensation. So now I indicated the water accumulation on the pipelines as red color over here. And after a period of time, let's say I want to open steam to the tank. Now I'm going to open the steam without draining this line. When I open it, even though I open it crack, the steam starts to come out, and I indicated the steam flow as black arrow, and it moves over the water. As it moves, it carries the slug of water, creating a similar effect as we see the waves over the beach, and it creates so high velocity that the water wave forms ahead of the steam, and as there is a bend on the pipe, an elbow or something, it creates a banging noise which is called as water hammer. So on a pipeline, if you take a hammer and hit it, you will hear a metallic clink noise. So the water banging on inside of the pipe creates a similar effect. So let us understand the concept of partial vacuum. Let's see the other picture here. So with this picture, I'm going to explain the similar scenario and the concept of partial vacuum. So as I said earlier, the steam has condensed with this valve shut without lagging, and water droplets are over here, and I'm going to open the steam. So the steam starts to flow like this, and then as it flows, the steam slightly, when it touches the water, it starts to condense. Since water is colder, and the wet steam which is coming out of the valve condenses into water, and this condensation along with the partial vacuum due to the earlier condensation of steam pulls the steam, which accelerates the velocity of the steam. And again, as the steam progresses, it touches this water droplet, and again some condensation happens, and as it condenses, it creates vacuum or partial vacuum, which again accelerates the steam, and thus it keeps on accelerating, reaching even sometimes 100 miles per hour speed, and then as it meets the elbow of a pipeline, it creates a banging noise, and thus this is called as water hammer. And let's say if you have a joint over here or gasket, you definitely will have a blowout either from the gaskets first, and after such banging due to over a period of time, the material over here becomes weak, and thus the steam starts to blow out through this. So this is called as the condensation induced water hammer. Well, here's other picture which is showing the
water hammer, which is of condensation induced type, or we can otherwise call it as a steam driven water hammer. Water is accumulated due to condensation, and once we open the valve, the steam drives this water, creating a banging noise. And this picture which is over here shows the steam which is creating a water hammer in a pipeline which already has lots of water. For example, boiler feed water line. So the water is filled up over here, and as the steam flows, it creates ripples, and thus these ripples form as big water waves and hits the pipeline, creating water hammer. And this happens on boiler feed lines and some freshwater lines, for example hot water circulating line, etc., if it's getting overheated more than 100 degrees. So thank you all for watching this video. For more videos, log on to dieselship.com.